Hi everyone, so welcome back to my channel Mathematical Swati 3226. So this is the second part of the video. The first part I have already uploaded, that is integration exercise 7.2 solution class 12. So I'll just show you that we had completed in the last video these 10 questions of exercise 7.2. So if you have not watched this video and you are struggling with integration questions, make sure you watch this video. I'm going to put the link in the description box. So please watch that video first and then watch this video, okay? So we had completed 10 questions in the last video. This is the second part, as I said. And in this, I'm going to start with the 11th question. Remember, these all are NCERT questions, and here I'm trying to make a detailed solution step by step so that you can understand everything. So let's start with the 11th question. And in the 11th question, we have to integrate x upon root over x plus 4 dx. And of course, there is a condition that x is greater than 0. Okay. Okay. So let's start with the solution. So you know that this is, as I said, that if you do proper practice, you will understand which expression you have to basically substitute. So yes, make sure you are practicing enough. So here I'm just going to take x plus 4 equals t. So if x plus 4 equals t, that if I do the derivative, if I take the derivative on both sides, this will become 1 because derivative of x with x is 1. Derivative of 4 is 0, so 1 plus 0, and then of course dx, and this is dt. So what I'm getting, 1 plus 0 is 1, 1 into dx is dx. So it is dx equals dt, right? So I can rewrite down the expression, and that will become integration x at the place of x. From this, I can see that x equals nothing but t minus 4. So I can write down this as t minus 4. Upon root over x plus 4, root over as it is, x plus 4 is t. So I can just substitute t. dx is dt from here, so therefore it is dt. Now this is very simple. You simply have to, separate the LCM here. So what I'm going to do, I'm going to write down this as t upon root t minus 4 upon root t dt. There is a property of integration that you can distribute, right? So therefore you can rewrite down this as t upon root t is same as t raised to half dt minus, here 4 is constant, so you can write down outside, and then 1 upon root t. Root t is here, t raised to half, again you can write down like this, and this is dt. Okay, let's move ahead. Here you can use the property of exponent, and that is if you have a raised to m upon a raised to n, that means a raised to m minus n. So using this property of exponent, you can write down this as integration t raised to 1 minus 1 upon 2 and then dt. This is for integration. There is another property that you are going to use here. If you have 1 upon e raised to m, that is same as a raised to negative m. So that means if you reciprocated that fraction, that is 1 upon a, then the, like whatever you have at the power, that will become negative, or the opposite exactly. So this will become t raised to minus half. This is the property of exponent that I have used, okay? So if you want to understand the exponent properly, I have made a video on the exponent as well. So if you want, I can put the link in the description box for that particular video as well. So I'm going to put 2 links in the description box. First is the integration part 1, and second is the property of exponent. So make sure you watch all the videos if you have any doubt in the exponent. Otherwise, you can continue with the first part and then this part. So this will become t raised to 1 minus 1 upon 2. Of course, this is 1 upon 2, right? dt, and this is minus 4. And integration of t raised to minus half. Here we are going to use this formula. We know that integration of x raised to n dx is x raised to n plus 1 upon n plus 1 plus constant of integration. So using this formula, this will become t raised to minus half plus 1 upon n plus 1. So it is minus half plus 1 again, and then plus constant of integration. Okay, so let me write down this as, any constant of integration. So if you want, you can write down this as C2, because for this, I'm going to write down C1, so I'm writing this for C2. And now integration of t raised to half will become t raised to half plus 1 upon half plus 1. That is the formula. And then, of course, the constant of integration that I'm writing as C1. Minus 4. If you simplify this, this is clearly minus half plus 1. It is going to be half only. If you have any doubt, I'm explaining that as well. So if you just take LCM, it is 2, it is minus 1, and it is 1 times 2 is 2, so 2 times 1 is 2. So it is clearly 1 upon 2. Okay, this was the understanding for the calculation. So t raised to half, and this has also become half only, and then plus C2. And let's simplify this further. Now this, if you simplify after taking LCM, this will become 3 upon 2, and this is, of course, 3 upon 2 plus constant of integration, and this is 4 upon 1 upon 2. So this 2 will go in the numerator because 4 divided by 1 upon 2 is same as 4 times 2 upon 1. That is 8 upon 1, which is 8 only. So it is 8, and then t is t, and then 1 upon 2 you can also write down like this, and then plus C2. Now I can write down this as, this is 3 upon 2 in the denominator, so it will basically become 2 upon 3. And this is t raised to 3 upon 2 as it is, minus 8, and then root t. And then for this C1 plus C2, I'm just using one constant. So if you want, you can also write down that where capital C is nothing but small c1 plus small c2. And now you just need to substitute the value of t. That is it. So what was the value of t that we had taken? We had taken the value of t to be x plus 4, right? So we just need to put here x plus 4 and then raised to 3 upon 2 minus 8 root over x plus 4 and then plus c. This is the answer. All right. So we are done with the 11th question. Now let's move to the 12th question. So let me write down the question. And so the 12th question, we have to integrate. So we have to integrate simply x cube minus 1 raised to 1 upon 3 times x raised to 5. Okay. So this is the question, and now we have to simplify this. So here what I'm going to substitute, I'm going to substitute x cube minus 1 to be t. So if x cube minus 1 is t, so if you do the derivative, this will become 3x squared. How? Because we know that derivative of x raised to n is nx raised to n minus 1. So using this formula, it will clearly become 3x squared. Derivative of 1 is 0, so no need to write down, and then dx equals dt. Now here I can write down this as x squared dx equals dt upon 3. Okay. Now I'm going to write down this integration question in a little different form. So this will become integration x cube minus 1 I have taken as t. So I can write down this as t raised to 1 upon 3. And then here x raised to 5. Can I not write down this as x squared times x cube? Yes, I can write down, because that is the property of exponent once again. That x raised to 2 dot x raised to 3 is nothing but x raised to 2 plus 3, that is x raised to 5. So I can write down using this property of exponent that x raised to 5 is x raised to 2 times x raised to 3. Now what I'm going to do here, I am going to substitute something more. So t raised to 1 upon 3 as it is. Can you notice here that we have x squared dx? We have here x squared dx. Now for this x squared dx, I can put dt upon 3. So I'm writing dt, and upon 3, I'm writing outside the integration because that's a constant. Now for this x cube, I can write down this as, from this, x cube is t plus 1, right? So I can substitute here x cube as t plus 1. Now this is very simple, because again, using the property of exponent, you can simplify this very easily. So what are we going to do? We are going to simplify this. So 1 upon 3 as it is, integration t raised to 1 upon 3 times t plus t raised to 1 upon 3 times 1, that is going to be t raised to 1 upon 3 only, and then dt. And now this will become 1 upon 3. Here again, using the property of exponent, we know that a raised to m times a raised to n is equal to a raised to m plus n. So using this property, t raised to 1 upon 3 plus 1, that is going to be 4 upon 3. And then plus t raised to 1 upon 3 dt. Okay. So what I'm going to do here is I'm going to simplify the integration directly. If you want, you can separate the integration. That means you can write down this as 1 upon 3 integration t raised to 4 upon 3 dt plus 1 upon 3 integration t raised to 1 upon 3 dt. But I'm going to simplify it like this. So what is integration of t raised to 4 upon 3? It is simply t raised to 4 upon 3 plus 1, that is 7 upon 3, using the formula x raised to n, right? If integration x raised to n is x raised to n plus 1 upon n plus 1, so using that formula, it is 4 upon 3 plus 1, that is 7 upon 3, and then of course upon 7 upon 3 here. Our integration of this is going to be t raised to 1 upon 3 plus 1, that is 4 upon 3, and this is also going to be 4 upon 3, and then plus the constant of integration. So if you simplify this, it will clearly become 1 upon 3, and if you simplify this, this will become 3 upon 7 t raised to 7 upon 3 plus this will become 3 upon 4 t raised to 4 upon 3 and then plus c. Now let's bring this 1 upon 3 that is outside the bracket inside. So clearly 1 upon 3 times 3 upon 7, 3 will get cancelled. So only 1 upon 7 t raised to 7 upon 3. Here also 3 will get cancelled because using the distributive property 1 upon 4 t raised to 4 upon 3 plus c. Now what was the value of t that we had taken? We had taken t as x cube minus 1. So we simply have to put that back. So 1 upon 7 t was x cube minus 1. So x cube minus 1 raised to 7 upon 3 plus 1 upon 4 again x cube minus 1 raised to 4 upon 3 plus c. This is the answer. So we are done with the 12th question as well. Now let's start with the 13th question. All right, so let's start with the 13th question. And in the 13th question, we have to integrate x square upon 2 plus 3 upon 2 plus 3x cube raised to cube dx. So again, for me, it's very simple to understand that what I'm going to substitute. I'm going to substitute simply 2 plus 3x cube as t. So 2 plus 3x cube equals t. So if you do the derivative of 2 is 0 because that's a constant, and derivative of 3x cube will become 3 as it is. And x cube derivative is 3x squared. You know the formula, right? Derivative of x raised to n. This is a very basic formula. So n times x raised to n minus 1. Using that formula, it is 3x squared. And of course, dx, and then of course, dt. Now from here, I'm just going to keep x squared here. Like I have explained all these things, that why am I keeping just x squared dx like this only? Everything I have explained in the first part of the video. So make sure you are watching that video. So x squared dx will simply become dt upon this 9 will come here. Now I'm going to rewrite my integration as integration. For this x squared dx, I can write down dt upon 9, right? So this will become 1 upon 9 outside and dt as it is. And then 1 upon 2 plus 3x cube, I can put t because that is here. That is what we had taken for t, and then cube. Now this is very simple using the property of exponent. You know that we can write down this t raised to 3, like 1 upon t raised to 3 as t raised to minus 3 dt. Now using the formula, this will clearly become x raised to n plus 1, that means n plus 1 upon n plus 1, and then plus the constant of integration. Now simply this will become 1 upon 9 t raised to minus 3 plus 1, that is minus 2 upon minus 2, right? Remember, it is getting multiplied, plus c. And this is nothing but minus 1 upon 18, because 9 times minus 2 is minus 18, which is same as minus 1 upon 18. T raised to minus 2, I can also write down as 1 upon t square, again using the property of exponent, and then plus constant of integration. Now this will become minus 1 upon 18 times t we have taken as 2 plus 3x cubed. So this will become 1 upon 2 plus 3x cubed square plus c. If you want, you can write down this little bit in the standard form by writing minus 1 upon 18 2 plus 3x cubed raised to 2 plus c. This is your solution. I hope you are understanding how I'm simplifying all the questions. And now it's time to move to the next question, that is the 14th question. So let me write down the 14th question for you. And in the 14th question, we have to integrate 1 upon log x raised to m. 1 upon x log x. Yes. So 1 upon x into log x raised to m, where x is greater than 0. And also there is one condition, that is m is not equal to 1. Okay, because if m is equal to 1, then it will be basically, like you will not be able to simplify it. That is why they have given this condition. Okay, so now let us start with the solution. So simply you are going to put here log x as t. This is very basic because I can see that the derivative is present over here. So you are going to put log x as t. So of course the derivative is 1 upon x dx equals dt. Now you can see, oh, I forgot dx here. Now you can see that you already have 1 upon x dx. For that you are going to substitute dt. So it will simply become the integration 1 upon x dx is dt, so simply dt, and then log x is t, so it is t raised to m. This is super simple to do. Okay, now what I'm going to do, I'm going to write down here t raised to minus m using the property of exponent. Now using the formula of integration, it will simply become t raised to n plus 1, that means minus m plus 1, and then again upon n plus 1, that is minus m plus 1. At the place of n, we have m, that is it, plus c. Now let's put the value of t, which is log x. So log x raised to minus m plus 1 upon minus m plus 1 plus c. That is the answer. If you want, you can simplify it by writing the minus term later on. So if you want, you can also write down this as log x raised to, instead of writing minus m plus 1, you can write down 1 minus m, which is same as this, and then upon 1 minus m, and then plus c. That is it. We are done with the solution. Now let's go to the 15th question. We are going super fast now, because I know that you have also become pro now if you're watching the video continuously properly. So yes, let's go to the next question, which is integration x upon 9 minus 4x square dx. So let's start with the solution. So here you need to decide that what are you going to put for t. So I'm going to put here 9 minus 4x square equals t. That's the smart way. That's a smarter way to decide which expression you have to put, because imagine you are putting just x square as t or 4 minus x square as t, then you will get something extra which is not in the integration. So that will create a problem. That is why it is best to put entire 9 minus 4x square as t. So now let us simplify this. If you do the derivative, 9, 0, derivative of 9 is 0, minus sign as it is, 4 as it is, derivative of x square is 2x, and then of course dx, and then dt. Now I'm going to put here only x dx, and this minus 4 times 2, that is minus 8, I'm going to substitute it, send it to the other side. So it is this. Therefore, I can rewrite the integration x dx as dt upon minus 8, which is same as minus 1 upon 8 dt, and this is simply 1 upon t. This is so simple now. Minus 1 upon 8 as it is, we know that by formula integration of 1 upon x is log x. So integration of 1 upon t is going to be log mod t, and then plus of course the constant of integration, and this will become minus 1 upon 8 log t here is 9 minus 4x square, and then plus c. That's the answer. Okay, so we are done with the 15th question as well. We are just going super fast now, which I'm liking it. Okay, so let's go to the 16th question. So in the 16th question, we have to integrate e raised to 2x plus 3. It's very simple. E raised to 2x plus 3 dx. So here again, the smarter way, the smart move will be that if you just put 2x plus 3 equals t. If you take the derivative, 2 outside, derivative of x with respect to x is 1, so 2 times 1, plus derivative of 3 is 0, so that is 0. And then, of course, dx equals dt. Now, 2 times 1 is 2, dx, so 2 dx equals dt. Now, I'm going to write down this as dx equals dt upon 2. Therefore, my integration will become e raised to t, dx will become dt upon 2, and this I can write on outside. Now, integration of the exponential function is the same function, so it is simply e raised to t again, and then plus c. So what is the answer? 1 upon 2 e raised to t is 2x plus 3, so 2x plus 3, and then plus c. That's your answer. Oh, wow. Let's move to the next question. That is our 17th question. Okay, so for 17th question, let me write down the question first. So in the 17th question, we simply have to integrate x upon e raised to x squared. Okay. So let's start with the solution. So here I'm going to substitute x squared as t. So what is the derivative? 2x dx equals dt. So x dx is dt upon 2. Very simple. Now, therefore, you can rewrite down your integration as x dx is dt upon 2. So dt as it is upon 2, I'm writing outside. 1 upon e raised to x squared is t, so it is t. Now, this I can write down as 1 upon 2 integration of, by using the property of exponent, it is e raised to minus t dt. All right. And now this will become 1 upon 2 integration e raised to minus t. Okay, I can do the integration here directly. So e raised to t integration is e raised to t, right? Like e raised to x integration is e raised to x. But if you have integration of e raised to minus x, it will become e raised to minus x upon minus 1. Okay, so whatever is the coefficient of this x that you have to divide. So this will become e raised to minus t as it is, and then of course minus 1 as well, and then plus constant integration. Clearly, this is nothing but minus 1 upon 2. E raised to minus t is your x squared. So it is minus x squared plus c. That is your answer. If you want, you can simplify it further by just using the exponent and keeping the power positive. So this will also become minus 1 upon 2 e raised to x squared, right? Using the property of exponent and then plus c. That's the answer. Okay, let's move to the 18th question. We are almost towards the end. So keep on watching, guys. Okay. So in the 18th question, we have to integrate. This is super simple. Integration e raised to tan inverse x upon. As soon as I'm writing this question, I'm just understanding, like, I just got it. But what do I have to substitute? So if you're good in derivative, it's just, very simple to understand that what do you want, like what do you have to substitute. So let us put here tan inverse x as t, because I know that the derivative of tan inverse x is 1 upon 1 plus x squared. That is given in the question. So it is 1 upon 1 plus x squared, and of course dx equals dt. Therefore, I'm going to rewrite down the integration. So integration, you can clearly see that 1 upon 1 plus x squared dx is dt. So I'm simply going to substitute e raised to tan inverse x as t, and then that dx upon 1 plus x squared, that is dt. So it is simply dt. Now you know that integration of e raised to t is e raised to t only. So e raised to t and then plus the constant of integration. Now your t is nothing but tan inverse x. It is tan inverse x plus c. See, it was looking so difficult. Oh, integration e raised to tan inverse x. But it was so simple. It was so simple. I hope you agree with what I'm saying. Okay, now let's move to the 19th question. And in the 19th question, we have to integrate e raised to 2x minus 1 upon e raised to 2x. Okay, there is one mistake that I'm doing. It is e raised to 2x minus 1. It is upon e raised to 2x plus 1. This minus 1 and plus 1, they are not on the power. Okay. So here, before we substitute, we are going to simplify it. Why are we going to simplify it? Because that will make our solution much, much easier. So what are we going to do? We are going to divide here the numerator as well as the denominator by e raised to x. So I can write down dividing numerator, that's the short form, and denominator by e raised to x. I'm going to get e raised to 2x minus 1 upon e raised to x upon e raised to 2x plus 1 upon e raised to x. You know that dividing the same thing in the numerator and denominator, it does not affect your question. Okay. Now, if you simplify this using the property of exponent, it will simply become e raised to 2x minus x, that is x, minus 1 upon e raised to x. Of course, it will become e raised to minus x upon this. If you simplify e raised to 2x upon e raised to x using the property of exponent, this will become e raised to 2x minus x, that is e raised to x, plus 1 upon e raised to x, that is e raised to minus x. Here, if you have any doubt how I did this, make sure you watch that video on like the property of exponent, because I'm just using the property of exponent here. That is simply a raised to m upon a raised to n is a raised to m minus n. That is it. Or I'm using 1 upon a raised to m as a raised to minus n. That is it. Okay, so I have finally this expression, and now I have to decide that what I'm going to substitute. So I'm going to substitute here the denominator. So put e raised to x plus e raised to minus x as t. Now let us differentiate this. So e raised to x is e raised to x. E raised to minus x is also e raised to minus x. But because we have here minus sign, so like, you know, if you are doing the derivative of e raised to minus x, it is minus e raised to minus x. So using this formula, this will become plus. Here it is already plus, and you are getting minus. So plus into minus is minus. So it is minus dx equals dt. Now this looks very interesting because I can see that we have the exact term in the question, which is this. So you are simply going to write down this as integration e raised to x minus e raised to x minus like e raised to minus x dx is nothing but it is dt. So it is dt upon this is t. Now you know that what is the integration of 1 upon t? It is simply log mod t plus c. And mod t, like you just need to put the value of t, that is e raised to x plus e raised to minus x plus c. That's the answer. All right, we are done with this question as well. Now let's move to the 20th question. So in the 20th question, you simply have to integrate e raised to 2x minus e raised to minus 2x upon e raised to 2x plus e raised to minus 2x dx. So you need to simplify this here. And I know that you can just see that this is almost similar to what we did just now. So yes, it is like, it is the simplified form. Already simplified form is given, okay? So you can directly put here e raised to 2x plus e raised to minus 2x as t. Now, if you do the derivative of this, it will become e raised to 2x, right? And then, of course, if you do by chain do the derivative of 2x, it will become 2 only. So times 2. Plus, this will become e raised to minus 2x as it is. And again, by chain rule, if you do the derivative of minus 2x, it is going to be minus 2. And then, of course, dx equals dt. All right, so this will become 2 e raised to 2x, and this is plus minus minus 2 e raised to minus 2x dx equals dt. Now from here, I can take 2 common. So I'm getting e raised to 2x minus e raised to minus 2x dx equals dt. So this will become e raised to 2x minus e raised to minus 2x dx equals dt upon 2. So therefore, I can write down this integration question as integration. For this expression, e raised to 2x minus e raised to minus 2x dx, we have dt upon 2. So I can write down this as integration dt upon 2 is, like I can write down outside, upon e raised to 2x plus e raised to minus 2x I have taken as t. So it is again t. See, we have reached almost to the same step. So it is 1 upon 2 integration of 1 upon 2. T is log mod t and then plus the constant of integration. So simply it will become 1 upon 2 log mod t. T is here e raised to 2x plus e raised to minus 2x plus the constant of integration. And that is our answer. Okay, now it's time to go to the 21st question quickly. So let's go to the 21st question. We are almost towards the end. So now we have to integrate tan square in bracket 2x minus 3 dx. Again, if you are very good in derivative, you should understand here that what do you need to substitute. So here, before you substitute, it is best if you use a formula, and that is sec square x minus tan square x is 1. So from here, can we not write down that sec square x minus 1 is tan square x? Yes. So using this formula, tan square x is sec square x minus 1. So tan square 2x minus 3 will become sec square 2x minus 3 minus 1 dx. Now the question is why I did this. Because here, if you take sec square, we know that what is the formula of integration of sec square x. We don't know, we do not have any formula for integration of tan square x. That is why we have substituted this. Now, what are we going to substitute here? So we are going to simply put 2x minus 3 as t. So if 2x minus 3 is t, that means this will become 2. Derivative of x with respect to x is 1. Minus this is 0 only, and then of course dx is equal to dt. So it is simply going to become dx equals dt upon 2. So therefore, I can write down the question as now this is your question, okay? Because we have rewritten this. So integration sec square 2x minus 3 I have taken as t, so t, and then minus 1 as it is, and dx is dt upon 2. So dt and then upon 2 I'm writing outside. Now here it's very simple. So 1 upon 2, we know that the integration of sec square x as sec square x is tan x. So this will simply become tan t, and then minus integration of 1, that is a constant, that is simply t, right? So this is t and then plus the constant of integration. Now this will become 1 upon 2. This is tan t is 2x minus 3, and then minus t is of course 2x minus 3, and then plus c. So this is the answer. If you want to simplify, of course, you can simplify this as well. Okay. All right. So let's move to the next question. That is the 23rd question. 22nd question. Yeah. 22nd question. So in the 22nd question, you have to integrate sec squared 7 minus 4x. Okay. So here you don't need to convert because you already know that we know the formula for sec square x. So simply you need to substitute here 7 minus 4x as t. It's very simple. The derivative of 7 is 0. So that is 0 minus 4 is outside. Derivative of x with respect to x is 1. So it is 1. And then of course dx equals dt. So clearly dx will become dt upon minus 4. So therefore you can write down your question as sec square 7 minus 4x as t, so sec square t, dx is dt upon minus 4, so I'm writing that outside. Now this is minus 1 upon 4. Integration of sec square x has a formula tan x. So it is tan t, and then of course plus constant of integration. Make sure whatever formula while doing integration question that you are using, you are writing on the side. I have not written it, but make sure you are doing it. So integration sec square x dx is nothing but tan x plus c. Okay, so minus 1 upon 4 tan t is 7 minus 4x and then plus c. That is your answer. So we are done with the 22nd question. Now it's time to move to the 23rd question because I'm going to finish this. I'm not going to make the third part of this video. So let's quickly do the 23rd question. And that is integration sine inverse x upon root over 1 minus x squared dx. Now this is also very simple because we know that the derivative of sine inverse x is 1 upon root over 1 minus x squared. So simply you are going to put here, let's start with the solution. So simply put sine inverse x to be t. So what is the derivative of sine inverse x? It is 1 upon root over 1 minus x squared. Remember, this is a formula. I'm not just writing it in any way. This is a formula. The derivative of sine inverse x is 1 upon root over 1 minus x squared. So using that formula, we got this. And of course, dx equals dt. Now this looks very simple. Integration sine inverse x as t. And then this dx upon root over 1 minus x squared, we have got dt here. So it is dt. Now you know that what is the integration of t? It is t square upon 2. Very simple. Plus the constant of integration. Now t is your sine inverse x. So sine inverse x whole square upon 2 plus c. That's your answer. Okay, so let's go to the 24th question. We are almost towards the end. Hang on. Don't leave the video. Make sure you are watching the video till the end. So in the 24th question, we have to integrate 2 cos x minus 3 sin x upon 6 cos x plus 4 sin x and then dx. So now we need to simplify this, and we are going to solve this by simplifying this integration question a little bit. So this question, the numerator as it is, from the denominator, sorry, this is 3 sin x. So from the denominator, we can absolutely take 2 common. So if you are taking 2 common, it is 3 cos x plus this is 2 sin x and then dx. Now again, this is very simple. You just need to put the denominator as t because I can see that its derivative is present on the top. So put 3 cos x plus 2 sin x as t, right? So 3 as it is because that's a constant, and derivative of cos x is minus sin x. So it is minus 3 sin x plus 2. Derivative of sin x is cos x. It is 2 cos x and then dx equals dt. Now, this is very simple. You can clearly see that whatever you are having here, that is in the denominator, right? 2 cos x minus 3 sin x minus 3 sin x. So for this particular term till here, we can substitute this as dt. Upon 2 as it is, and this is t, so it is t. 1 upon 2 outside, then we have just integration of 1 upon t dt, and integration of 1 upon t, we all know it is log mod t plus c. So it is simply 1 upon 2 log mod t. T we have substituted it here. 3 cos x plus 2 sin x and then plus constant of integration. So that is your answer. We are done with the 24th question. Now it's time to move to the 25th question. So let's do the 25th question now. So let me write down the question first. So in the 25th question, we have to integrate 1 upon cos square x into 1 minus tan x whole square dx. So here we are going to simplify this again very easily. So what I'm going to do, I'm going to use a formula here, and that is, we know that 1 upon cos x is sec x. So if I have 1 upon cos square x, it will become sec square x. So using that formula, I can write down this 1 upon cos square x as sec square x. And then this is 1 minus tan x as it is, like whole square dx. Now here, after simplifying this, it is very simple to do the derivative. We are simply going to put 1 minus tan x as t. Now derivative of 1 is 0, so no need to write down that, minus sign as it is. Derivative of tan x is sec square x. So that is why it is sec square x dx equals dt. So this is nothing but sec square x dx equals minus dt. Okay, so therefore we can write down this as integration sec square dx is minus dt upon 1 minus tan x, that is t, so it is t square. Simply this will become minus outside, integration 1 upon t square using the property of exponent, this is t raised to minus 2 dt, and this will become minus, integration of this is n plus 1, that means minus 2 plus 1 upon n plus 1, that is means minus 2 plus 1 plus the constant of integration. This will become minus t raised to minus 2 plus 1 minus 1 upon, this is also minus 1 plus c. Now this minus will become plus, so it is simply t raised to minus 1 plus c. T raised to minus 1 by the property of exponent, it will become 1 upon t plus c, and t is nothing but 1 minus tan x. Therefore the answer is 1 upon 1 minus tan x plus c. That's the answer. We are done with the 25th question as well. Now let's go to the 26th question. Okay, so I'm hoping that you are understanding all the questions easily, just the way I'm solving, because for me it's very simple. I'm solving it very easily. So I hope just the way I'm solving it very easily, you are understanding it also very easily. So the next is, we have to integrate cos root x upon root x dx. So here what are we going to do? We are going to substitute, of course, root x. So let us put root x as t. Root x is same as x raised to half, that is t. Now if you do the derivative using the formula, that is derivative of x raised to n, that is n times x raised to n minus 1. So using that formula, it is 1 upon 2 x raised to half minus 1, right? So it is half minus 1, that is 1 upon 2. So it is 1 upon 2 dx equals dt. So that is simply root x dx equal 2 dt, right? Or you can write down this as dx as, one second, 1 upon n minus 1. Yeah, that is correct. 1 upon 2 minus 1, it is going to be minus. Okay, that was the mistake. It is minus. That is why I was thinking that why I'm not getting the derivative on the top. Anyway, so it is minus 1 upon 2, right? So this is minus 1 upon 2. That means I can rewrite around this as 1 upon 2 as it is. This is x raised to minus half. That means 1 upon x raised to half using the property of exponent. And this will become 1 upon root x dx equals 2 dt. Now I can rewrite down the question as integration cos root x as t. And for this dx upon root x, we have 2 dt. So it will simply become 2 outside and dt. So 2 as it is, we know that integration of cos t is sin t. So it is sin t, and then plus the constant of integration. 2 sin t is root x, so 2 sin root x plus c. That's your answer. All right, let's go to the 27th question, and let me write down that question. Okay, so we are on the 27th question, and in the 27th question, we have to integrate root sine 2x cos 2x dx. That is the question. So this is also very simple. We are going to substitute sine 2x as t. So if you are putting sine 2x as t, and if you do the derivative, sine x derivative was cos x. So this will become cos 2x. But by using the chain rule, if you do the derivative of 2x, it is just 2. So 2 cos 2x dx equals dt. So clearly cos 2x dx will become dt upon 2. So therefore, your question, we can rewrite down this as integration root over sine 2x is root t, and for cos 2x dx it is dt upon 2. So dt and upon 2 outside. Now this will become 1 upon 2 integration of root t will become, because it is t raised to half, so if you use the formula half plus 1 and upon half plus 1 plus c. Now this will become half t raised to half plus 1, that is 3 upon 2, and this is also 3 upon 2 plus c. So if you just simplify this, 2 will go on the top. So 2 upon 2, and then of course 3 as well. T raised to 3 upon 2 plus c. Clearly 2 will get cancelled. So we are getting 1 upon 3. T here is sine 2x and raised to 3 upon 2 plus c. That's the answer. Okay, so that was the answer. This is 27. This was 27th question. Now let's move to the 29th question. Okay, I just want to see how many questions we have. And then I'll tell you that how many questions I'm going to do. So we have total 39 questions. So what I'm going to do, I am going to basically solve till 30th question. For the rest 9, I think I have to make the third part of the video as well. So yes, no problem. I'm just going to solve the next question, that is the 20. Okay, I'm at 27th question. So I have basically 39 questions. So it will be basically 12 more questions. So what I'm going to do, I'm going to end this video right here. And in the next part of the video, I'm going to solve the questions from 28 to 39. Because if I'll solve like those questions, the video will be very, very long, which I don't want now, because I can see that there are 39 questions. So this is the end of the video. I hope you have understood this video. If you have understood, please like this video and share it with your friends. Also, don't forget to subscribe to my channel. I'm just hoping to see you super soon with the third part of this video, where I'm going to finish the questions from 28 to 39. Thank you so much for watching.